In this lesson, we'll look at some foundations of creating graphical user interfaces in Java. There are actually 3 popular libraries for creating GUIs in Java, but we'll restrict ourselves to one called Swing. This is a really powerful, fully featured GUI toolkit, so of course we'll only be scratching the surface of what it can do. It's also a part of the core Java SE distribution, so you'll know it's available to you. In a Java GUI, almost everything that's visible on the screen is a component. A component might be a button or a text area or a drop-down list, for example. But there's also a special kind of component called a container. The job of a container is to hold other components. But since a container actually is a component, we can put containers inside containers too. That way we can build GUI layouts that have nicely organized regions, and even build pluggable interfaces that would allow us to reuse a part of the GUI in another program if we wanted to. That's actually one of 2 founding principles on which GUIs are built. If you're interested, that one's based on a design pattern called composite. There's another principle, which is that since Java is platform independent, we cannot make assumptions about the pixel dimensions of anything in our GUI. Instead, we have to describe things in a relative way and let the system work out how best to present the components. To support this idea, there's an interface called Layout Manager. This interface is implemented by several concrete classes that offer different ways of describing a layout. We'll look at one of these, called a grid layout, in just a moment. So let's dive into building some real code and see what it does. We're going to look at this project called GUI1. The first thing we'll need to do is to actually create a top-level container called a JFrame. We're going to need an import for that. A JFrame is the top-level window that will have the controls, like these up here, surrounding it. But if we simply create this is just an object in memory, and the system has no way of knowing that we actually want to have this visible on the screen. After all, we could have a situation in which some piece of our graphical user interface is hidden for a while and pops up in response to a user doing something, so the system can't just assume that we want it visible immediately. The way we'd make it visible is actually to call a method on the JFrame that says setVisibleTrue. You can probably guess that if we said setVisibleFalse, it would make the frame disappear. Well, it turns out if we run this by itself, it's still not going to be terribly useful because that frame is probably going to be infinitely small, so we might actually just not see it at all. What we need to do before we make it visible is to actually give it a size. There are several ways to give a component like this a size, but the one we're going to use is actually somewhat cheating. We're going to use absolute dimensions for its boundaries. So what we do is we call this method setBounds, and we tell it we want the top left corner 10 pixels in and 10 pixels down, and we want its width to be 300 pixels and its height to be 200 pixels. Remember what I said about not really being a good thing to use pixel dimensions, but for now, this is a good way of setting our top-level window. So if we save that and run it, we'll notice that this empty frame pops up here. Drag it down into the middle. There's nothing in it. I can resize it, and it has a title bar at the top. That, you'll notice, is the same title bar that we specified in here when we created it. There's something a little interesting about this, though. If we click on the close button, the program is still running. Notice the little red box here, that's the stop button that we can use to deliberately and manually kill a program, and it still says run. So let's kill it, and it finally says build stop, and see what we can do to fix that. The issue here is that it's not fair to assume that just because we click that close button, we want to kill the entire program. There are other possibilities. We might just be closing this window. So the way this GUI system is set up, it doesn't make any assumptions of that sort, but we can tell it what we want it to do. So the way that we can tell it, there is a convenient method, setDefaultClose and there are several possibilities for what we might do when we click that close, but what we want to do is to cause the JVM to actually exit. So we call this method setDefaultClose and we give it the parameter JFrame exit on close. So let's save that again and run it. And we should see now that if we click on the close button, it does in fact complete the execution of the program. It's no longer running, the little red button's gone away, and it says build successful. So that's a step forward. The next thing we'd like to do with our program is to actually add a little bit more behavior to it. And as we said before, we can't go sticking components at specific pixel dimensions and expect things to work well. So the very first thing we're going to have to do is decide on a layout manager that we're going to use with this. Well, probably the simplest one to use is one called a grid layout. We'll get the import for that. A grid layout assumes that you will divide the area of your window into exactly equal sized rows and columns. We can specify the number of rows and the number of columns when we create the grid layout. What will then happen is as we add components to this container, the J-frame, it will put them first in the top left and then moving to the right along the row, and then it will move down onto the next row and add them like that. Well, this one is going to be 2 by 2 components, so there will be 2 cells widthwise and 2 cells vertically, so we'll have 4 cells in total. The next thing we'll need to do is actually add a component to it. So we'll have to create the component and then add it to the layout. So the way we can do that is first we create a button. So we declare a variable JButtonB and create it, new JButton. The text in the argument to the constructor will be the label. Let's get the import for that. And then we tell the JFrame that we want to add that component, the button. Let's save that and run it. Notice that we now have this button and we can click on it. The layout manager has gotten slightly confused because we told it we wanted 2 rows and 2 columns, but then we only gave it 1 component. So it made its best guess. We'll find in a moment or two as we add more components that the layout will behave as a 2 by 2 grid like we told it to. Let's go ahead and add a bunch more components to complete that grid. So we've added quite a lot of stuff here, and we'll need some imports. So let's take a look at what we've now got. We have our original button that we create here. Then we create a component called a text field that we add here. And we give this text some initial text, edit this. A text field is a single line text component. Then we create a JPanel. A JPanel is actually another container. The plan is going to be that we're going to put into that container 3 more components, these JRadio buttons. Each JRadio button has a label, English, Francais. Notice here we use a Unicode literal for the C with a little curly thing underneath it that they call a cedilla. That's the hexadecimal code E7, and Deutsch. In the case where we create the radio button with the second argument true, that one says this one should already be selected. Of course, radio buttons have a special behavior that when you press one, the others pop out. And you might have multiple collections of radio buttons on one graphical user interface, and you don't want them all to pop out if they're in sets. So the way we tell them what set they belong to is to create this thing called a button group and add each of those JRadio buttons to the button group. Now, all the buttons in this button group, if you push one of them, it will automatically unpush the others. Inside the panel, we're going to present these 3 radio buttons. And the way we need to do that, of course, is first to set a layout manager. So we set a layout manager using the grid layout, which has 3 rows and 1 column. And then we add each of those radio buttons into the panel. The next thing we do, we create an array of 3 strings and another component called a JList based on those labels. So then what we do is we add our button to the JFrame, followed by our text field to the JFrame, our panel to the JFrame, and remember this panel already contains other components, and our list to the JFrame. Then we still have our set default close operation, our bounds, and our set visible. So let's save this and run it. So now you can see our button has moved into the top left corner, and we can still click on it. Our text field allows us to enter text here. It is a single line text field. We could use a text area instead if we wanted to have multiple lines. And then our radio buttons, all three of them appear in this one cell. But remember that we said that they are actually in a panel. The panel really doesn't show up. It's just a placeholder component. And because of the group that we added them to, when we click one, the others unclick automatically. And then we have this list component, which again presents within that one cell and offers multiple options within it that we can click on. So there we have it. Our graphical user interface is constructed using a top-level container, almost always a JFrame. That will have a layout manager which decides how components are positioned on that layout. And the grid layout is a nice, easy one to use. It's not terribly imaginative or very pretty. It always sets things out so that the vertical and horizontal space is divided equally based on the number of rows and columns you specify. Then we created a J button and a J text field. Those are nice simple components. Then we created our J panel and put several radio buttons into it. We also put the radio buttons into a logical group so that only one of them would be checked at a time. We ensured that the layout of those radio buttons were 3 rows and 1 column so that those within the panel would lay out nicely. Then we created our J list with 3 text labels in there and added the whole lot to the JFrame. Set our close operation so that the program will stop when we press the close button, gave it a physical size and position on the screen, and finally made it visible.